Chalco, welcome to the session, and we are happy that you are safe here. So if you can, Chalco, put your camera off, and we will give the floor to the water project to Hans and Lohan. Thank you very much, Hans.
Thank you as well, and welcome everybody. I'm pleased to present today the award project on behalf of the Water Consortium. And together with Loha, I think I can give you some insights into the project and into the use cases which have been demonstrated and being demonstrated in this project. So please, let's move to the next slide, or maybe even in the next slide. The award project is located within the Horizon 2020 framework in this topic: efficient and safe connected automated heavy-duty vehicles in real logistics operations. The award project itself is has a consortium of 29 partners, as you can see here on this slide. So all over Europe, we have, I think, very qualified partners to really demonstrate also these real logistics operations. And as the title award already suggested, this is an all-weather project, so the focus is clearly on demonstrating the operations also in harsh weather conditions. The project has a budget of about 26 million. Thanks, you can move on to the next slide, that's fine. Yes, thank you. And I think I will focus just here on the core of, or the heart of the project, which I think is, or are the 4 use cases. As you can see here, we have here 4 images of the use cases, starting from top with the port use case. You can see here a Turberg vehicle, which is, let's say, or the demonstration is located in Vladingen, so at the site of DFDS. Then we have the hub-to-hub vehicle, which is the second image from the top, which is a Carmack vehicle. And this demonstration took place in Austria at the 2 sites of Rotax and DB Schenker. Then the third use case and third vehicle is the TLD vehicle, which was or is deployed at the airport in Oslo at Avinor. And last but not least is the forklift, which is demonstrated or will be demonstrated in Austria by AIT. All the 4 use cases have one in common, of course. It's the, let's say, adverse weather conditions. So all of them should be demonstrated in real logistics operations. And before the demonstration and the deployment, of course, we were eager to really also check and test the safety of these vehicles. So here we also did some very intense testing in compliance with the ISO 26262 standard and taking into account also SOTIF recommendations. For the vehicle or the vehicles itself, we of course have here multiple sensors from the companies as listed here: Foresight, Continental, Alaska, Navtec, integrated, which are suited then for harsh weather conditions. And here the focus is clearly on this 24/7 availability. And also we have the teleoperation function from the company Utopia integrated and demonstrated for these use cases. Finally, we have in place a fleet management system for all of the use cases, which on the one hand is really for monitoring and supervising the operations on site. Next slide, please. And then I will, I think, start with the first demonstration, which is the airport. So thanks again. For the airport, as mentioned before, we have the TLD vehicle in operation. The TLD vehicle is from the French company here. It's the so-called EasyTow airport tractor. This tractor has a maximum speed of 15 kilometers per hour and is or was used in the 40 tons configuration. Next, please. Before demonstration, as said before, we were of course testing and having a close look at the safety of these vehicles. The safety-related real-life tests were performed at our proving ground in Austria. So on the upper left, you can see a top view of the test track, where we have also used our out-terrain plant for really testing reproducible harsh weather conditions. And on the right side, for example, you can see now a setup. Sorry, in this presentation, I think the video will not work. But here you can see that we really challenged the vehicles in really harsh weather conditions, which means also at night with heavy rain, with various dummies, pedestrians, and passenger cars to really simulate real environments and to check where we really have the boundaries and the edge cases for these operations. Next slide, please. After the testing, the deployment was, in this case, at the airport in Oslo. So here you can see again a top view of the airport area. As you can imagine, the requirements and restrictions at an airport are quite tough. So here the setup of the use case is as follows. You can see here with the red lines indicated where we have, let's say, the key points of the autonomous operation. So basically we have on the top the waiting point where the vehicle is waiting for its missions. Then finally the vehicle needs to be moved down to the second line from the top where the vehicle then let's say enters its area of autonomous operation. And basically at the third line from the top, it's indicated here as start auto mission station. The vehicle then goes down to the container storage, and from there it moves again up to the end auto mission station as indicated here. And this is done during normal operation at the airport. And the operation, I think, is running until end of this year. But I think that's more or less it, just to give you a grasp of this one demonstration. And with this, I think I want to move on to the next demonstration, which is the port demonstration. The port is located in Vladingen. As you can see here on the map, we have here the Terberg vehicle, is also shown here on the right side. So this is really a truck with a long trailer on its back, equipped also with sensors, as you can see here on the right. And the maximum speed of this vehicle is now at 25 kilometers per hour. Next, please. Similar to the airport use case, also this vehicle, of course, was tested beforehand on the proving ground. Here, one major difference is, of course, that we have a different setup, different environment. So, for example, as you can see here on the upper picture, we also had a roundabout as a testing scenario. So we have, for example, cut-in scenarios where the vehicle needs to react on time and safely before being able to put into operation there. Again, we have different setups with pedestrians, cars, and so on, and of course also in harsh weather conditions. Next slide, please. The demonstration itself took place at the port. So on the upper left, you can see a top view picture of the port area. As you can imagine, this area is again quite crowded. So on the, let's say, main part of the area, you will find some containers parked here in this herringbone pattern. And the operation itself took place in 3 steps or 3 phases. The first phase is now indicated here by the orange line. So this was basically the shunting of containers on terminal. The second part was then basically the access to the public road. So here it was also entering and exiting the port terminal and entering public road. And the third one, to my perspective, the most challenging, was then also the loading of a trailer onto a ship, which is indicated by the line number 3. And yeah, thanks. Next use case is the forklift. So the forklift use case is using this Palfinger Grayler. So this is the vehicle platform indicated on the upper left. And this vehicle is usually intended for remote control. So there's also no driver seat on the vehicle. And this vehicle is now being automated for the loading and unloading of a trailer, as shown here on the right picture. And this is an off-road forklift, which is then also used for this use case here. And on the next slide, I think you can directly see then the operational environment. We just carried out the safety and SOTIF testing of this vehicle last week at really harsh weather conditions in Austria, because now it's getting winter, so it's really not nice to be outside. Neither it's for the autonomous vehicle, of course, but here for the deployment, so really the demonstration, which is just about to start, the forklift will be then loading and unloading pallets on a truck in this area as shown here on this picture. And still we have then, of course, the operator responsible for supervision via our remote control. And with this, I would like to move on to the fourth use case, which is the hub-to-hub. The hub-to-hub use case is based on this Carmack vehicle, as shown here in the right picture, from company Carmack in Ulm in Germany. And this vehicle is limited to a speed of 20 kilometers per hour in autonomous mode. Next slide, please. For ensuring safe operation, again, we had the safety testing at the brewing ground. As you can see here now, again, a different or a similar setup as before. Again, tests with pedestrian dummies, with passenger cars, also a cut-in scenario. This use case is also on public road. So here we, of course, need to expect also different scenarios than on a company side. But of course, objects like pallets and barriers, as we have at the company sites, are as well part of the testing, which was conducted before demonstration. Next slide, please. Here you can now see the top view, or let's say an illustration of the route between the two company sites, the two hubs at Rotax and DB Schenker in Austria. On the lower side, you can see now also here that this is kind of the main road. So this route between the two hubs is quite challenging. It's just about 600 meters in length in one direction, but still we have a main road, side roads, unregulated crossings, this underpass. So I think we have a good mixture of very complex scenarios. And here the vehicle was then in operation. And this vehicle was also connected via CATS communication with traffic lights, which are also indicated here on the lower right. Next, please. The second main part of this hub-to-hub demonstration was then also the demonstration of the teleoperation function. As you can see here, we had a similar setup at in a controlled environment at the brewing ground, again in Austria. You can see here now on the lower left, this is the teleoperation setup, which was then used in the second part as a replacement for the onboard operator, which was still needed for the operation on public road. And here the teleoperator was really available as remote assistance and in case the vehicle needed support. And with this, I think I would like to move to the next slide, because I think here I have also a bit some learnings from this use case. So we from Digitrans are also the coordinator and test site leader for this hub-to-hub use case. Therefore, I just want to give you some more insights here. I will try to keep it short, but in principle, what we found also during operations on public roads is, of course, I mean, I guess it's obvious for most of the participants here, the legal framework needs to be established. So especially for this demonstration in Austria, the legal framework was adapted for this demonstration, and this was now, of course, possible. One, I think, key ingredient is, of course, the integration in the traffic flow, especially on public roads. We, of course, need to expect mixed traffic, which is quite challenging for autonomous vehicles. And for this purpose, we also needed to set up traffic lights out of safety reasons. For example, on the main road, we had here a speed limit of 60 kilometers per hour. You can imagine with a vehicle which is maximum at 20 kilometers per hour, you have quite some speed difference, and also entering and leaving the crossings is as quite safety critical. What we saw here is also that, especially in the beginning, when the traffic lights needed to be red a bit longer, which means up to 1-2 minutes, other road users simply ignored the red lights, especially during the evening hours, because they were, maybe a bit upset. But of course, this needs to be taken into account when planning such use cases. The performance overall was pretty good. So here we were really satisfied with the performance of the vehicle and also with the setup at the use case site. Here, I think one very good point was also at the private sites, at the 2 hubs, and including the reversing, which could be performed with high accuracy. The technology itself is already quite major, but of course there's some space for improvements. For example, with hard weather conditions, we know that there are still limitations, so there's, I think, still some work to do. And I guess the mixed traffic is one of the biggest challenges here, especially also the communication with other traffic participants, and of course the availability to get this really on the road. To really get benefits out of this automation, I guess it's also obvious that, of course, the overall process, especially in logistics, needs to be considered, because it does not pay off to really just automate a very small part of this whole process. So I think the whole process needs to be adapted and optimized as well. And just to give a few numbers here for the operation itself. So for this very small let's say area, so about 600 meters route, the humans operated the vehicle, which is comparable to this setup here, with 16 kilometers per hour, while the automation was slower with 6.4 kilometers per hour. I think as a real enabler for these operations, we can really say that the calibration is one of the key parameters here. So especially during this operation on public road, we always had to have an onboard operator available in the vehicle. So as long as we have a person in the vehicle, we won't get any real benefit as a business case. I think that's pretty clear. And calibration, I think, is one of the first steps into the correct direction. So here for realistic applications, this would be, I think, a real game changer. And of course, one of the biggest points here is, of course, the communication between the vehicle and its environment. For example, traffic lights, infrastructure like weather stations, gates, and so on and so forth. I think with this, the deployment of such a vehicles will be really also facilitated. And finally, a last point here from my side is, of course, the acceptance. I think it's clear, especially on public roads and on company sites, employees also need to be taken into account. Here we need to also consider the interaction between the automated vehicle and the humans around. So I think here the focus should be also on the HMIs and really the communication between the stakeholders. And with this, I think I would like to hand over to Loa. I think, Loa, you're still here.
Yes, I'm
for
here.
the
Can you hear me?
second part of the presentation. Thanks.
Am I audible? Can you hear me?
I can hear you, yes.
Oh, perfect. Then next slide, please. I just wanted to highlight a little bit our joint efforts with the ALICE working group on CCAM in logistic operations. First of all, I really appreciate actually the action and initiative, Fernando and everyone on ALICE. While award is actually really closing to its last month, I would say, as Anas shared all the lessons learned from our project, we want to actually leave the legacy behind, and such initiatives give us the opportunity to not only share the lessons learned, but also try to continue our efforts on the research aspect as well as technology development and further developments in the CCAM area. Mainly, of course, the focus of award is logistic, and that's why I'm really happy that there is a working group in ALICE that focuses mainly on logistic operations and CCAM. So we are already engaged in multiple initiatives, not only with CCAM, but also other projects. I just shared with everyone the link to the upcoming event, and that is a liaison activity between Podium, MODI, Award, the three flagship projects of European Union on autonomous vehicles in different use cases. So I really encourage everyone actually to join or register for the workshop where we will discuss with you different topics, specifically the use cases that Anas mentioned that are quite common with the coming projects such as MODI, where they start actually from hub to hub. So we want in this workshop, we want to discuss with you. I remember one of the slides of Armin was actually, and also Andrea, where the European Commission actually wants to know whether some of the prominent use cases or the promising use cases of CCAM in different areas, and this is exactly one of the questions we would like to answer in this workshop. So I really encourage you to attend the workshop and make your voice heard, and also give us some insights that can be used in order to write a roadmap for the adoption of autonomous heavy-duty autonomous vehicles in logistics. Then we would also really like to further share our lessons learned from a work project, not only through our website, but also ALICE's knowledge platform and other platforms such as Zenodo. So please follow us. We will be also sharing some policy recommendations as some activities, as result of some activities in the WORD project. I would say in few months, the report will be released. We would also really, most of the partners in a work project are really research-oriented partners, but even if they are industrial partners, they have this research focus, and they would like to foster further research initiatives with other partners in the industry. So we'd like to actually continue our investigations through EU-funded projects, but also national and international funding opportunities. So do reach to us, but also we would like, through this initiative of ALICE, we would like to further discuss such initiatives and get involved. Also, we will be we will be actually promoting, and we will be part of the events that will be organized by ALICE. So we will have further opportunities actually to discuss other topics and details. Maxim, giving back the floor to you.